Okay, this video is going to be on how to create a mesh, and a mesh primarily to use for rapid prototyping, which is milling or SLA or deposition or all those kind of things that make a little plastic or wax part that you turn into shiny jewelry. So the command that we're going to use to do that, first, rather than going file export and exporting a particular file format, what I want to do is just show what the mesh settings are doing. And so if we go over to utilities, and right here is mesh from NURBS object, or you can simply type the word mesh, whatever you find faster. So I'm going to click that, and if you've never done a mesh, or if you messed around with these settings, or you just installed Rhino, or you're from another planet or something, I don't know. You may have this come up as polygon mesh options and have it on simple controls. And this is not a good way to make a mesh. This is just less triangles, this is more, but it's not taking into consideration any of the surfaces. It's just a shotgun approach, if you will, or a way to just pick a setting quickly. We always want to do detailed controls. Okay? And I'm going to start with this all zeroed out, so nothing is taking into account anything. Now, I'm going to start to compare some of these settings and what's really going on, but we do have to start somewhere. The place that I am going to start is I'm going to unpack, or I'm going to turn off pack textures. Okay? Okay, so pack textures, what it is it's for texture mapping, and it has to do with the mapping coordinates that are applied to a mesh surface. And generally this goes for paint programs where you can like paint right on the mesh and so on. And I really don't have any application for that. From what I understand, the one that Rhino generates isn't often the way some of the more popular programs want that mesh information anyway. So I'm not saying it's good or bad. I'm saying for our application, we don't need it. So there's no sense tracking that. I am going to leave Refine Mesh on, because Refine Mesh, after it does the initial meshing, then Rhino will come over and look at the settings here and use this to generate the mesh that it's going to make. And so we want these settings to take into effect what's going to be created by the mesh. And so we want this left on. Okay, we'll come back to these momentarily. Okay, so for our initial introduction to this, I'm going to skip down past density, and really there's two main ways that a mesh is going to be made on a surface. The first way is maximum edge length, and what this setting is going to do, and let's put this at 0.2. Okay, and what this is going to do is this is going to make a uniform mesh over the surface. All right. So let's take a look at this. Okay, and here's what I mean by uniform. Each square is the exact same size. Okay, basically. And so the maximum distance the edge of this can be is 0.2. So let's turn on point, and let's go to measure distance. And so we'll measure from this point to this point. And what do you know? The maximum it can be is 0.2. So we're at 0.199. I'd say that's pretty close. Okay, so that's what that means. What this is good for is this mesh is very uniform, obviously, and very predictable. If you have Claytrix, I can say that this mesh going into Claytrix is going to be very good for that, because the mesh is even and there's not flat spots in the mesh where there's big triangles. Okay. The other thing that it's good for is if we're going to come over here to transform and let's say bend, okay? And we come over and let's turn off snaps now. And we come over and we bend this. This is very predictable because there's plenty of information for this to get bent. Get bent. So anyway, there's a lot of information for this to use to reproduce the new surface during the bend command. Alright. Okay, so let's go back to mesh. And so maximum edge length, again, picks this number and does it uniformly throughout the part. The other one that I want to compare to that is maximum distance edge to surface. Okay, let's do this one at 0.01. And then I'll get into what settings I would recommend for rapid prototyping and why. But just for demonstration's sake, I'm going to use 0.01 here. Okay, so now let's look at this mesh, and we'll pull it over here. Okay, so now what does this do? Well, this looks at the surface, the true NURB surface, and it makes polygons that cover that surface tight where it needs to be tight to show this fillet surface, and loose or flat where there's big flat areas that don't take a lot of detail. Now what it does here is really pretty clever. Here it finds that it can adhere to the surface well if it makes the triangle down this way to a point, back over, and so on. So it can go around here much more efficiently than this one. Now just offhand, if we come over here and we bend this one, it doesn't bend right. Why? Because there's no information here for it to bend with. It's just taking these vertices and skewing them over, trying to bend them, but it's not introducing any new ones. Now really, the reason that it doesn't introduce new ones is because you cannot remesh a mesh. Okay? So we'll come back to that as well, but that's a general rule. If you have a mesh like so, and you say, oh, okay, I want to mesh this mesh, I want to change it. See, it won't even, you can't select surfaces or polysurface the mesh, you can't remesh a mesh. That's a lot of mesh. It's a big mesh. So, okay, so there's one reason why you might want to use this setting is so that there's information enough to do what you're going to do down the road. And so you got to be thinking about, what am I going to do with my mesh? If you're just going to go rapid prototype it, this one's a lot better. Why? Because it, and let's shade these without the mesh here. So we'll do plastic. This doesn't look any different in smoothness from the original NURBS, right? And this one certainly doesn't look any better than this one. I mean, both surfaces are realized. But where's the payoff? Well, if we go to Object Information, we'll see that this mesh has 19,200 and some vertices. A vertice is right here where the points of the triangle come together. This is a vertice. And it's made out of almost 21,000 polygons. And that's this one that we're looking at. Alright? So 20,900 polygons. Whereas this one has only 2,900 vertices, and instead of almost 21,000 polygons, it has 3,000. And yet, we've realized basically the same surface. We just didn't need all this info here, if we're just going to grow or mill or whatever this part. Okay, so having said that, what's really going on when we do this setting right here, maximum distance edge to surface? Okay, well, we have the true NURB surface, and the true NURB surface is what it is. How's that? Confucius says nothing on me. But when we make the mesh surface over it, then we want to stay as close to this true surface as we can without making this huge mesh like the maximum edge length mesh. Because you do enough of that and your system resources go down, and Windows comes up and says, I'm out of memory, and nobody likes that message. So maximum distance edge to surf uses what's called the chord length and the chord height. Okay, so here's my example of that. Let me sketch it out real quick. Okay, here's my example. Let's say this is a basketball. The closest I got was making it orange. And let's say on our basketball we want to cover it up with polygons, and we're going to use clipboards. So the size of my polygons are clipboards. So here's the edge of a clipboard, here's the edge of a clipboard, and so on. Okay, the length of this clipboard is the chord. Okay. Okay, now the distance between the furthest point of the chord to the true surface is called the chordal height. Okay, this is the height of the chord furthest edge to the surface. Okay, and the setting that we're going to use to control that, let's do mesh. This could also be called the chordal tolerance, but it's the maximum distance of the edge of the furthest point of the chord to the surface, or the chordal height. Okay, so here if we use clipboards, then we get quite a distance, quite a large height value to the chord. If we use a smaller surface, I don't know, maybe a CD case in this example, then the chord length is shorter, and so